So we are to, on this chapter test that's in the book, they ask us to do these things. They want us to draw a plane N that contains two lines that intersect at B. So they give us an example of a plane here for question 2 and 3. So we're going to follow that example that they have here, only we're going to call it plane N. They happen to call this one plane R, so we'll call this one plane N. And then we get two lines. Remember, they need arrows on them to indicate that they are lines. And then they need to intersect at B. So all we're doing is just drawing this with line 1, line 2, and intersection at B. We need to make sure that we label it that it is plane N. So we go through and we do that, and then we're good to go. And so then we'll just clear this up some for us. Go ahead and just delete this here. Oh, whoops. And so now we're going to go on to question 2. And question 2 is asking us to draw 4 coplanar points, or 4 non-coplanar points. And I think what they mean is 4 coplanar points, or not to draw, but use the figure. And what they mean is 4 coplanar points, because we don't have 4 non-coplanar points, because E, A, B, and C all happen to be in the plane R. The only non-coplanar point that we happen to have here is at D. D is the only one that is non-coplanar with these 4 points. So I think what they're asking is 4 coplanar points, because remember, coplanar means that they happen to lie on the same plane. So if I were to say collinear, they happen to lie on the same line. So these 3 points would be collinear because they're on the same line, whereas this point would not be collinear with these other 3 points because it is not on the same line. So I'm pretty sure that what they mean is 4 coplanar points. If they had asked, give a point that is non-coplanar with plane R, then we would say plane D. So that's what is going on there. The book is asking a question that doesn't make any sense. And so now we are going to line containing B and E. So a line containing B and E. Here's B and E. So what line is this? This is this line right here. And what is that line? Well, we are going to just name it BC because we have this point B and we have this point C. And then in order to make that line, we put the little line symbol on the top because this means line BC. And this means line segment BC, and this means ray BC, and if we just say BC, then that's the measure of BC, or its length of BC. So just remembering all of that so that we can get that done for us. And then we go on to question 4. Question 4 says that we happen to have, if we draw a number line, it's helpful for us to see what's going on. We have, here is 0. We have 1, 2, 3. So here is A, and that is at -3. And then B, if this is 1, where is B? B is right here at 0.5. So what is the distance from A to B? So we just count that. 1, 2, 3 and a half, right? That's 0.5. So that's 3 plus 0.5. So that's 3.5 is equal to AB, the length of AB. Remember, there's no line segment over it, so that's its length. Or we can use the absolute value method, which says that it's equal to the absolute value of the difference between the points. So A is -3, subtract 0.5, and then we take the absolute value. Well, they're both negative, so what do? We add them together, 3.5, -3.5, the absolute value. And the absolute value means to make positive, so 3.5 is equal to AB. And so you can see here that we ended up with the same answer using either method. So we make sure that you use a method that you happen to know that you can do correctly. Either method on the test works just fine. And then we go to question 5. And question 5 tells us that we have EF and FG, and we're given the lengths of all of those. Well, we happen to know that if I take EF plus FG, it's equal to the whole thing. So if this is 5 and this is 10, how long is the whole thing? Well, the whole thing is 15, right? So I can use that by saying 5 plus 10 is equal to 15. Is that true? Yes. So I'm going to use this same pattern here. And so how do we want you to do this on the test? Well, you write them out, right? So you have your info here. So you would say 6x minus 4 and 3x, and then 5x plus 8. And so then you're going to say these added together is equal to this. So 6x minus 4 plus 3x is equal to 5x minus 8. So we combine like terms first. So I'm going to do my 6x and my 3x. So added together gives me 9x minus 4 is equal to 5x minus 8. I need to now get my x's on the same side. So I have an x here and an x here. I need to get those on the same side, so I get rid of my smallest x first. So minus 3x and minus 5x and minus 5x. 5x minus 5x is 0. 0 minus 8 is negative 8. 9x minus 5x is 4x minus 4. And so then what do we do here? Well, we are going to add 4. And so then we get 4x is equal to negative 4. And then we divide by 4, because the opposite of multiplying by 4 is dividing. Divide by 4. And so then x is equal to negative 1. Are we done, though, once we found x equal to negative 1? No, because we need to take this and we have to substitute this back into our x. So we're going to substitute this not into that x, sorry. What do they want us to find? EF. So they want us to find EF. And what is EF? EF is 6x minus 4. So we substitute that in right there. So we have 6x minus 4, and we substitute it. It's 6 times negative 1 minus 4. 6 times negative 1 is negative 6 minus 4. They're both negative, so we add them together and keep the negative, so negative 10. So how long is EF? EF is equal to negative 10. So let's continue on with question 6. So question 6 tells us that HJ, it tells us that we have HK and that J is the midpoint. So we're looking here and we see that J is the midpoint. So what do we want to do? We want to put in congruent marks. Congruent marks help us to see visually that they are the congruent, that they are the same size, because J is the midpoint, and midpoint means that it splits it in half, so we put those marks in there. So then we know that 3x plus 5 and 9x minus 3 have to be equal, because this and this are both congruent, which means they're the same size. So then we know that they're equal. Now we can solve algebraically for x. So we minus 3x because we get rid of the smallest x. And then we have 5 is equal to 6x minus 3. And then we do the opposite of subtracting 3, which is adding 3. And so then we have 5, 6, 7, 8 is equal to 6x. So then I'm just looking here to make sure that I've done this correctly. Subtract 3x, plus 5, minus 3. So I've added 3. So then we divide by 6, divide by 6. I look at this here and I think to myself, the reason why I was going back and double checking that I was doing all of this correct is because I have a fraction here. So I have 8 over 6 is equal to x. Is that right? Well, let's plug this back in to both here and here and see if we end up with like a whole number or something like that. Because we could end up with a fraction and then end up with a whole number here. So we're going to plug that in. 3 times by 8 over 6 plus 5. And so then I can go through here and I can see that, okay, I'm going to reduce these down. So then this is going to be 8 over 2 plus 5, which 8 divided by 2 is 4, plus 5 is 9. Now I want to see if this also comes out to be 9. If this came out to be 9, then I know that 8 over 6 is correct, so I'm going to double check that. So then I say 9 times by 8 over 6 minus 3. And so then I can divide both of those by 3. So I divide both of those by 3, and I get 3 times by 8 over 2, and 8 divided by 2 is 4, so 3 times by 4 minus 3. 3 times by 4 is 12, minus 3 is 9. So they both happen to come out to be 9. So then 8 over 6 is 9. So that means that we most likely did this correct. And so if both of these are 9, then we go over here and we pay attention to what the question was, and it says find HI, JK, and HK. So, or HJ. HJ is 9, JK is 9, so then HK is 18. So we know 18, HJ, and JK. So then, now we're going to go on to question 7. So we'll go on to question 7 and take a look and see what we can do on question 7. Classify each angle by its measure. So they're just wanting to know, is it acute, obtuse, or right, or a straight angle? And so then this is less than 90, so it's going to be acute. And this is 90, so it's going to be a right angle. And this is 125, so it's going to be obtuse. That's all they mean when they say classify. And then we go into question 10. Question 10 tells us that TV bisects RTS. So first thing we do is we need to get, what is that? That is a angle. So make sure, let's get that angle written out. So we draw out the angle. We say RTS because T is in the middle. T is here at the vertex. So now we have this angle, and then we are told that TV, ray TV, so from TV bisects. And what do we mean by bisects? Well, that means that it split it in half. So then this and this are congruent, so we put in our congruent arcs. So we're told RTV, so we have RTV, and that is 16x minus 6, and VTS is 13x minus 9. So we're going to get those written in. So we write those in, 16x minus 6 and 13x plus 9. And since we know that these are congruent, we're going to set these equal to each other. So we're going to set those equal to each other by saying that 16x minus 6 is equal to 13x plus 9. And so then we do this the exact same way that we did the addition of the line segments. We notice here that these are going to be equal to each other, and then we solve for x in the same way. And if we solve for x in the same way, we're going to get rid of the smallest x first. So 13x minus 13x. 13x minus 13x is 0, so we're left with 9 on the right-hand side. 16x minus 13x is going to be 3x. minus 6. So then what do? We add 6 to both sides, add 6 to both sides. And so then 3x is equal to 15, divide by 3, x is equal to 5. So we find out that x is equal to 5, but we are not done because we want to know what RTV is. We want to know what RTV is. So what do we do? So what do we do with RTV? Well, we're going to substitute the x in here, and so if we substitute x in, we are going to end up with 16x minus 6. We substitute the 5 in. 16 times by 5 minus 6, and so then 16 times by 5 is going to be 80 minus 6 is going to be 74 degrees. And so we say the measure of angle RTV is equal to 74 degrees. And then we will have found the answer to that problem. So now we're going to go on to question 11. Question 11 tells us an angle's measure is 5 degrees less than 3 times the measure of its supplement. And what does supplement mean? Means that it adds up to 180 degrees, so that they add up to 180 degrees, or they sum up to 180 degrees. So an angle's measure is 5 degrees less than 3 times the measure of its supplement. So some angle x plus s is equal to 180 degrees. Right? So these two angles have to add up to 180 degrees. So an angle's measure is 5 degrees less than 3 times the measure of its supplement. So we're going to get this to be written in terms of its supplement. And so x is equal to minus 5 degrees less than 3 times the measure of its supplement. So we know that it's 5 degrees less than 3 times its supplement. So then what can we do? We can substitute this in for x. So that's what we are going to do. We're going to substitute that in for x. So then we get this written in. So 3s minus 5 plus s is equal to 180 degrees. So 3s plus s is 4s minus 5 is equal to 180. So we add 5, and so then 4s is equal to 185. And then what do we do here? We are going to divide that by 4. So 185 divided by 4 gives us that s is equal to 46.25. And so if x is 46.25, what is x? Because that's what we wanted to find. So what are we going to do? We're going to substitute this right back into here and solve for x. So s is 46.25, so 3 times by 46.25 minus 5. So we run through that. So we times that by 3. 46.25 times by 3 is 100 and 38.75, we minus 5, and then we end up with 133.75 is equal to the measure that we're looking for. So if I'm going to get rid of all of this right here. So then we came up with that the angle was 133.75 and its supplement was 46.25 as our answers. And now we can go here and we can take a look at we're looking here at this here, and we want to know whether they're adjacent, only adjacent, or adjacent and form a linear pair or not adjacent. So it's adjacent and form a linear pair, only adjacent or not adjacent. And remember, adjacent means that they're next to and they share the same angle. So 2 and 3. So we've got angle 2 and we have angle 3. And they happen to be only adjacent because they happen to have the same vertex. They have the same vertex. So this angle and this angle, they share the same vertex. So then in this case we would say that they are only adjacent, because if they formed a linear pair, they would have formed a straight line, or 180 degrees, we would say. But 2 and 3 make 90 degrees essentially, or as close to 90 as we can tell from the drawing. We don't actually know if it is 90, but it's close to 90. So it doesn't form a straight line 180 degrees, so this is only adjacent. And then 4 and 5. So we have a straight line here, and 4 splits that up. So if this was 30 degrees, then this would be 150 degrees, because that's 180, because straight line. And so then in this case they form a straight line, and they happen to share a side. They share this side right here, and and 2 and 3 share that side. So we're making sure they share a side and they share a vertex. So then in this case here, this is adjacent and linear. And then 1 and 4. So here's 1 and here's 4. And in this case, they only share a vertex. They only share this vertex. I've got 2 sides here, and then I've got 2 sides here, and they share this vertex. This side is not shared, this side is not shared, this side is not shared, and this side is not shared, because this is just angle 1 and angle 4. So this is not adjacent. Find the perimeter and area of a rectangle. So the perimeter, so we have a rectangle here with 8 and 4. And so then we get this here. And so then this is 8 and this is 8 and this is 4, and the perimeter means we just are going to add all of those up. And so we happen to have 2 4s and 2 8s, which makes sense because the equation for perimeter of a rectangle is equal to 2L plus 2W, which is equal to 2 times by 8 plus 2 times by 4. And then if we run that through our calculator here, we'll wait for that to pop up here. So 2 times by 8 is 16, right? So 2 times by 8 is 16. So we have 16 plus 8, right? And then 16 plus 8 is 24. So 24. So the perimeter of the rectangle is 24. 24 what? Well, let's take a look here and see what they gave us. We want to make sure that we put our units onto it if they gave us the unit. And they did give us units. They gave us units of feet. So then the perimeter has to be in units of feet. So then we make sure that we put that onto our thing so that this is feet. And then the area of a rectangle is equal length times width, which is going to be 8 times by 4. And then 8 times by 4 is 32. So we end up with 32, but it's what? Area is always feet squared. It's always length squared, so we need to make sure that we say that the area is equal to feet squared. And if they had told us that it was in inches, then this would have been 24 inches. This would be 32 inches squared. So make sure that we are getting our units on there. And so then we're on to question 16. Find the circumference of a circle to the nearest tenth. So we happen to have a circle here, and we're given the radius of 15. And so then what's the equation for circumference of a circle? Circumference is 2 pi r. So what do we do with this r? We're going to substitute it into our equation. So this is equal to 2 pi r. So we can run that through here. This is going to be 15. So this is going to be 2 times by 15, which is 30 pi. So then we're done there, but we cannot forget that this is meters, so this is meters. So if we were on Khan Academy, we would be done because they would ask us in terms of pi, but this time it's to the nearest tenth. So the nearest tenth means to 1 decimal place. So we run this through if we're using 3.14 as pi. So we say 30 times by 3.14, we end up with 94.2 meters. I've rounded it to the nearest tenth. So right here is what we're looking for. And then, but do not forget, it says circumference and area. Some of you had forgotten to do both of those on your test. So you want to do both circumference and area. So this r was equal to 15m. So the equation for area of a circle is pi r squared. So this is going to be pi squared. So we run that through our calculator, and we say 15 times by 15 is equal to 225 pi. 225 pi feet squared, but it's asking to the nearest tenth, so we're going to type in 3.14 times by 3.14, so we end up with 706.5 feet squared is our area. And then we do the same thing here for D. D is equal to 25 feet. So how do we do that? We have our circle and we draw in our diameter, and that's 25 feet. But what we want to do is remember what the radius is, and the radius is half of that. So half of 25 is going to be 12.5 is equal to r. And then once we have r, we run it just through our area and our circumference, the area and circumference, just like we did last time, and we will end up with let's see here, 17 is going to be 78.5 feet, and that's for the circumference, and 490.9 feet squared. So circumference and area, just like we would have done last time. All we had to do on that one is turn diameter into radius by dividing by 2. Do not forget the units. And so then same thing is going on here, right? We have our circle. This whole thing is going to be 2.8 centimeters, so we divide that by 2. So then 2.8 divided by 2 gives us 1.4 centimeters. So we need to make sure we just run it through like we did on the previous ones, when we get 8.8 centimeters. And we end up with 6.2 centimeters squared. Do not forget your units. You will need to have your units. And so this is circumference is equal to and area is equal to. So make sure that you always put down your units. And then here we find the midpoints with these endpoints. And so we need to use our midpoint formula. Our midpoint formula is x2 plus x1 divided by 2. We're taking the average of the x's and the average of the y's. And then that's going to be our midpoints. So we are going to label these -4, 6, 3, 2. So x1, y1. x2, y2, and then we substitute these into our equation. So then x2 is 3 plus x1 is -4 divided by 2, comma, and then y2 is 2 and y1 is 6 divided by 2. And then we just run those through our calculator. Remember that you want to do the top and then you do the bottom. So when you do 3 plus -4, that's really just 3 minus 4, which is -1/2. So it's -1/2. 2 plus 6 is 7, 8. And 8 divided by 2 is going to be 4. So it's, what is our midpoint? It's -1/2, 4. Or we can say -0.5, 4. Either one of those works. The main thing is to remember our midpoint formula. So how do you go about finding an endpoint? When you're given the midpoint. So if you're given the midpoint, if we know that the midpoint is equal to the average of the endpoints, if the midpoint of x, if the midpoint of x is equal to the average of the endpoints, then we can plug in our endpoints and then solve for our missing x. So we're told that our midpoint is -5, 1. Well, so what is the midpoint of our x? It's -5. So -5 is equal to, and then we have L. What's that? That's 2 is equal to 2 plus x divided by 2. And then we can solve for the missing x by timesing by 2, timesing by 2. They cancel out, and we're left with -10 is equal to 2 plus x. So what do we do here? Well, we subtract 2, so -12 is equal to x. So so far for n, we have -12 as our x, and we'll do the same thing for our y. So we plug in the x of the y for our midpoint is equal to y2 plus y1 divided by 2. So what is our y? Well, it's 1. And what is our y for our other endpoint? It is 4 plus y over 2. So we divide by 2, or we multiply by 2, multiply by 2. So 2 is equal to 4 plus y. So we subtract 4, so we end up with negative 2 is equal to y. So it's negative 12, comma, negative 2 as our endpoint, our missing endpoint. So negative 12, comma, negative 2. And then we can double check this by doing a quick graph and see, does it make sense? So if we have our graph here, and we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we have this 2, comma 4. So 1, 2, 1, 2, 3, 4. So we're here for L. And then we have our midpoint at negative 5, 1. So 1, 2, 3, 4, 5, 1. And so then we're going to be somewhere along this line right here. So we're going to be here, or somewhere here like this, right? And so this is down 2, so we're going to go down 2. 1, 2, so we're down here, about. But this is, and so then we're going to be over 1, 2, 3, 4, 5, 6, 7. So we're going to be over 1, 2, 3, 4, 5, 6, 7. So we're going to be down here about. But this is not down 2. This is down 3 because this is 1 and this is at 4, right? So this is down 3, so we go down 1, 2, we go 1, 2, 3, so this is going to be down here at negative 2. So that's about where we are down here at negative, somewhere around there. So that seems like it makes sense, like it might be right. Assuming that all of our things were evenly spaced, which they were not. So that seems close enough to say that we're most likely right to have that to be our endpoint at negative 12, negative 2. And then what we have is, we want to know, is AB congruent to CD? And congruent means, here, these are the line segments, so are they going to have the same lengths? So AB, what is the length of AB? Well, the length of AB is going to mean, we're going to need to know our distance formula. So our distance formula, D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we just run that through here. So we have x1, y1, x2, y2. So x1 is going to be negative 5. So first, x2 is negative 1 minus negative 5 squared plus y2 is going to be 3 minus 1 squared. So we run that through. We run that through on our calculator. So we're going to say negative 1 minus negative 5 gives us the square root of 4 squared plus 3 minus 1 is 2 squared. So then this is going to be the square root of 16 plus 4 is going to be equal to the square root of 20. So then we want to find out, is this also equal to the square root of 20? So we're going to run that through, and we're going to double check to see, is that equal to the square root of 20? Because right now we know that AB equals the square root of 20. So let's double check on CD. So C, 1, 4, D, 4, 1, x1, y1, x2, y2. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And so then we can plug in our x2 is 4. So 4 minus 1 squared plus y2 is 1 minus 4 squared. So 4 minus 1 is going to be 3. So 3 squared plus 1 minus 4 is negative 3 squared. And 3 squared is 9 plus 9 is going to give us the square root of 18. And the square root of 18 is not the square root of 20. So they are not congruent because they are not the same length. And so we could also look at this. The square root of 20, if we run that through our calculator, second square root 20, that gives us approximately 4.47. And the square root of 18, if we take the square root of 18, gives us approximately 4.24. And we can see that these numbers are not the same, which we already saw over there. But in case you did not get the square root of 20 and the square root of 18, if you just plugged it all into your calculator and you got the decimals, you can also see that neither one happen to be the same. So they are not congruent to each other, so they are not equal to each other. Or they're not equal to each other, therefore they're not congruent to each other. And then now we are to identify the transformations here on 22. So here's R, and here's R, here's Q, here's Q, here's S, here's S. So this is not a reflection, because if it was a reflection then Q would be here, Q prime, but that's not the case. So what do we have here? Well, it's not a dilation because it didn't grow and it didn't shrink. What we do have is probably a rotation about this center point, because if I don't know if that'll grab that or not. Yeah, well, it's not grabbing it. But so I'm going to draw this right here, and then I'm going to draw this right here, and then I'm going to try to grab this like this. Nope, that doesn't work either. Well, anyway, this is going to be a rotation because it's going to rotate. It's going to rotate about this point right here. So this is going to be a rotation, and I'll come back and we're going to take a look here at this next one.